Hello students, welcome you all in this video where we are going to solve section B chemistry of CBSE sample question paper class 10 2025-26. Already I have solved section A biology and I have uploaded the video on my channel. Visit my channel, watch my videos, and if you are getting little bit also help from these all the videos, please consider subscribing my channel. So let's start with section B chemistry. So in this section, question number 17 is a multiple choice question which is going to carry 1 mark. So we will start with the question. Which of the following equation represent redox reaction and what are the values for P and Q in this equation? So here we have two equation 1 and equation 2. We have to find out which equation is redox reaction and then we have to find out the values of P and Q. These are the coefficients used to balance these equations, so that we have to find out. So here we have first equation, Fe2O3 plus aluminium gives aluminium oxide Al2O3 plus iron Fe, and here the heat is liberated. Because of this large amount of heat, whatever iron we are getting, it is in the liquid form. Then equation 2 is C4H10, that is butane, react with oxygen. It is nothing but a combustion reaction, and we are going to get carbon dioxide and water. Here water is in the gaseous form because this is a combustion reaction, so heat will be liberated, and due to large amount of heat, whatever water is going to form, that all liquid water will evaporate to become gas. So these are the two reactions or the equations which is given, and we have four options. Out of this, correct one we have to choose. So option A, only equation 1 is redox reaction and P is 1 and Q is 3. Option B, both equation 1 and 2 are redox and P is 2 and Q is 4. Option C, only equation 2 is redox and P is 2 and Q is 10. Option D, both equation 1 and 2 are redox, P is 2 and Q is 10. So here we have to focus on which reaction is the redox reaction. What is redox reaction? The redox, if you see this word, there are two words which are combined. The first word is red, that is nothing but reduction, and the second word is ox, and that is nothing but oxidation. So here reduction and oxidation both, if simultaneously takes place in the reaction, then that reaction is called as redox reaction. So we have to find out the equation in which the elements, if one substance is undergoing oxidation, then the other one should go reduction simultaneously, and that we can do it by understanding the oxidation states of these all the elements. So what we have to do, we have to find out the oxidation state of Fe, oxygen, aluminium, carbon, hydrogen, and this oxygen, and we have to check is that oxidation state has been changed when it becomes a product, and whatever change has occurred, in that change it has increased or decreased, means it has lost electron or it has gained electron, that we have to find out. If it loses electron, then it is undergoing oxidation. If it gains electron, then it undergoes reduction. And based on that knowledge, we can easily find out which equation is oxidation, redox, and which equation is a correctly balanced one. So let me start with the finding oxidation state of all the elements. So here I will take first equation number 1, and the equation number 1 is Fe2O3 plus aluminium. So write down the coefficient, that is 2 aluminium. Here I am not writing the states because I am going to write the oxidation state, so we will get confused a little bit, so I am not writing the states. Gives Al2O3 plus PFE, and heat is liberated. So here I will write H for heat. Now we have to find out the oxidation state. So first I will take, let me write it little bit of down so that you should not get confused. Fe2O3. So in this Fe2O3, I will find out the oxidation of iron, and for that, as we have here 2 iron, so I will take 2. Oxidation state now I don't know, so I will take X plus, now here 3 oxygen, and oxidation state of oxygen is, as we know, it is -2, and overall oxidation state here there is no number, +2, -2, nothing is there, so we should consider it as 0. So that's why I'll write it here 0. So is equals to 0. Overall oxidation state is 0. Now 2 into x is 2x, plus or minus minus 3 2s are 6. So 2x, so here write down equal to 0. 2x is equals to shift this minus 6 on that side, so it will be 6, and x is equals to 6 divided by 2, and here I am going to get answer x is equals to 2 1s are 2, 2 3s are 6, so here plus 3. So oxidation state of Fe in Fe2O3 it is plus 3, so I'll write it here plus 3. We got, and for oxygen I told it was minus 2, so minus 2. Aluminium, if you focus here, this is a atom, so element don't have any oxidation state, so it is a pure, it is in a pure state, so zero oxidation state. Now reactant side is completed. Now come to the product side. Product side, here we have Fe, again it is a pure, so here oxidation state is 0, and for Al2O3 we have to find out the oxidation state of aluminium. So for that I will write it here Al2O3, and same process we have to use. I don't know the oxidation state of aluminium, but I know how many aluminium, 2, so therefore 2. Because I don't know the oxidation state, I'll take x plus 3, oxygen is minus 2, is equals to overall it is 0. So now, so solid 2x plus or minus minus 6 is equals to 0. I hope you're understanding. 2x minus 6, that side we will shift. X is equals to, we are going to get same answer, that is x is equals to plus 3. So this is the oxidation state of aluminium. So I'll write it here plus 3, and here I'll write down for oxygen it is minus 2, sorry, so I'll write it here minus 2. Now if you see this reaction, if you focus the reaction, see the iron in the reactant side, this is the reactant side, so in reactant side iron was plus 3, and once it becomes the product it became 0. Here it was plus 3 and now it became 0. So here the oxidation state has got decreased. So what is the meaning of this? Once the oxidation state has got decreased, means iron has reduced. So here I will write Fe reduced. So we can write like this. Now focus on oxygen. Oxygen here also minus 2, here also minus 2. So there will be no change. Now see aluminium. Aluminium, this side it was 0, but on other side if you see it is plus 3. So what is the meaning of this? Earlier it was 0. Now after the reaction in product it is plus 3, means oxidation state has increased. So here aluminium has got oxidized. So here I'll write oxidized. So by this, what we can say, in this reaction, iron has reduced, aluminum has oxidized. So this is a redox reaction. So it is proved that this is redox reaction. So equation 1 is redox reaction. Now we will see equation 2 and then we will go for balancing. So I'll write here equation 2. So equation 2 is, that is 2C4H10, then 13O2 gives, it undergoes combustion, it gives 8CO2 plus Q, we have to find out H2O. So this is the reaction. Now again in this we will find out the oxidation states of all. So here if you see oxygen, it is in the pure state, so 0. Here we have 0 oxidation state. We have to find out first for carbon. For carbon, I'll take here C4H10. Now we have to find out for carbon. Therefore, I will take X for carbon. So we have 4 carbon. So I took 4. X is the oxidation state of carbon, which we don't know. So I'll took X. Then plus, how many hydrogen? 10. Oxygen state of hydrogen, as we all know, plus 1. And overall it is 0. So I wrote 0. So 4X plus 10 is equals to 0. Then it will be 4x, shift 10 on that side, so it will be minus 10. X keep as it is, minus 10 divided by 4. So here what we will get, if you divide this, x value we will get 2.5. 2.5. 4 2s are 8, again 2 will remain, then 4 5s are 20. So here we got 2.5, so I will write here 2.5 for carbon, and hydrogen it is plus 1. Now, if you go on the other side, here we have CO2. So for CO2, we will find it out. CO2, I will write it here, CO2. So as I told, I don't know the carbon oxidation state. So carbon here only 1. So X plus 2, and oxygen state, as we all know, it is minus 2, is equals to 0. So x plus or minus, minus 4 is equals to 0. Shift on that side, so we will get, so here the oxygen state of carbon became 4. So this I will write it here 4. Oxygen we know here minus 2. Hydrogen here it is plus 1. Oxygen here it is minus 2. Now if you focus on this reaction, in this reaction here I forgot to write the sign, sorry for this mistake. So here it is minus 2.5 and here also we have to write minus 2.5. Now if you focus the equation, carbon on this side, if you see, carbon was minus 2.5 and after the reaction it became plus 4. You can see this, it became plus 4. So the oxidation state of this has got increased. I hope you are understanding. The oxidation state of this has got increased. It from minus 2.5 it became plus 4. So what is the meaning of this? The meaning is carbon has got oxidized. So here for this reaction I will write it here somewhere. It has got oxidized. Carbon has got oxidized. And see oxygen, here it was 0. It was 0 and on the other side if you see, oxygen has become minus 2. So oxidation state has decreased. So oxygen has reduced. So carbon has oxidized and oxygen has reduced. So in this reaction also, one substance has undergone oxidation, other substance has undergone reduction. Therefore, this reaction is also a redox reaction. So in this equation I can write, so this is also a redox reaction. So now if you see, both the reactions are redox. If you focus on the option, only first option is only equation 1 is redox. So this is a wrong option. Both equation 1 and 2 are redox. So this is correct. Only equation 2 is redox. So this is also wrong. Both equation 1 and 2 are redox. So now we have two choice, B or D. From B or D, any one option is correct. That we have to decide with the help of P and Q value. Now to find out P and Q, if you see in the first reaction, this side Fe, how many we have? We have 2. Oxygen, how many we have? 3. Other side, oxygens are correctly balanced, 3 and 3. But iron, here we have 2, but here we have only 1. If I write here 2 in place of P, then this reaction will be balanced. So P should be how much? 2. I hope you are understanding. So in the first equation, P should be 2. Now, this is very easy to balance. In the second one, if you see here, carbon 4 2s are 8. Hydrogen, here how many we have? Hydrogen, if you see, H10 and this is 2. So here 20 hydrogen we have. Oxygen 13 2s are 26 we have. This side if you see, carbon how many we have? CO2 we have here 8. So carbon is balanced, 8 correctly balanced. 8 2s are 16 oxygen and here we have 26 total. So 16 oxygen means how many are still remaining? 10 oxygens are remaining. Hydrogen we have 20, here we have 2 hydrogen. So we want 20. So if you multiply with 10 in place of Q, if I take 10, then hydrogens becomes 20, oxygens becomes 10 and oxygen correctly balanced 26. And like this if you see, then the equation 2 Q should be 10. And according to this, if you see in the options, option B, P is 2, Q is 4. So this is also a wrong option. And option D, P is 2 and Q is 10. So this is the correct option. That's why option D is correct. So here in answer I have wrote D, both equation 1 and 2 are redox reaction and P should be 2 and Q should be 10. So this is the correct answer and correct explanation for question number 17. I hope you understood the answer of this question. I have explained very neatly. Little bit of mixing I have done, but try to understand slowly step by step. You will understand. Whenever you try to understand this, write this whole thing in your book. So whenever some such type of question comes, you can apply these ideas in your different questions. So now question number 18, again a multiple choice question which is going to carry 1 mark. 4 statements about the reaction of oxides with dilute hydrochloric acid and aqueous sodium hydroxide are listed. So here we have four statements about the reaction of oxides with dilute hydrochloric acid and with aqueous sodium hydroxide. So hydrochloric acid is acid, aqueous sodium hydroxide is base. So we are going to react oxides with acid and base, and here we have four statements. So statement 1, aluminium oxide react with both dilute hydrochloric acid and aqueous sodium hydroxide. Second statement, calcium oxide reacts with dilute hydrochloric acid and aqueous sodium hydroxide. Third statement, zinc oxide reacts with both dilute hydrochloric acid and aqueous sodium hydroxide. And the fourth statement is sulfur dioxide does not react with either dilute hydrochloric acid or aqueous sodium hydroxide. So these are the four statements, and now in the options they have given option 1 and option 2. So here we have to see which statements are correct. If statement 1 and statement 2 is correct, then correct mark option A. If statement 1 and statement 3 is correct, then mark B, and so on. So now we have to start with the answer. So we will start with the answer. Now first statement, if you see, aluminium oxide. What is aluminium oxide? Aluminium oxide is Al2O3. It is called aluminium oxide. Then aluminium oxide reacts with both dilute hydrochloric acid and an aqueous sodium hydroxide, they are saying. So before going to the answer, first we will see the types of oxides. So types of oxides. So we have three type of oxides. First one, acidic. First one, acidic oxides. And who will give acidic oxides? All non-metals. Non-metals will give acidic oxides. Then second, we have basic oxides. And basic oxides we are going to get from metals. We are going to get from metals. And then we have one more type which are called as amphoteric oxides. So amphoteric oxides means what? The oxides which show both the properties. They will act as acid, sometimes they will act as base also. So acidic oxide means the oxides which behave as acid, acidic property they will show. Basic oxides will show basic property. Amphoteric means which shows both the properties, acidic as well as basic. So here this aluminium oxide, it is showing both the character. It is amphoteric, amphoteric, and therefore I'll write it here. It is an amphoteric oxide. Therefore, it has the property to react with both acid as well as base. So if you see here, hydrochloric acid, it is a acid, and aqueous sodium hydroxide, it is base. And the statement says aluminium oxide reacts with both, and it is correct because it is amphoteric. So first option is statement is correct. In the second statement, if you see calcium oxide, what is the formula of calcium oxide? CaO, calcium oxide. This will react with dilute hydrochloric acid and aqueous sodium hydroxide, they are saying. Means they are saying this calcium oxide will react with both acid as well as base. But calcium is a metal, and metal will give basic oxide. So this is basic oxide. I hope you are understanding. If it is a basic oxide, it has basic properties. And if it has a basic property, base will react with only acids. It cannot react with bases. Base cannot react with base. And therefore, second statement is a wrong statement. Then third statement, if you say zinc oxide, the formula is ZNO, zinc oxide. This is again a amphoteric oxide. So I'll write it here. This is again a amphoteric oxide. And according to this, it should react with both. So zinc oxide reacts with both dilute hydrochloric acid as well as aqueous sodium hydroxide. So this is also correct statement. If you see statement 4, sulfur dioxide, di means 2. So does not react with either dilute hydrochloric acid or aqueous, means they are saying sulfur dioxide will not react with both acid as well as both base. But in this sulfur dioxide, sulfur is non-metal. Non-metal will give acidic oxide. So here I'll write SO2 is acidic oxide. I hope you are understanding. Acidic oxide. To know these all, you should know the basics first. which is acid, which is base, and which is amphoteric. So if this is an acidic oxide, it should react with base. It should not react with acid. So this is acid. So it should not react with acid. And they have told sulfur dioxide will not react with acid. But they are saying it will not react with base also. But as we all know, because it is acidic, it should react with base. It should react with the sodium hydroxide. So this statement is wrong. And if according to these all, if you see the statement 1, it is correct. Statement 3 is correct. So search in the option. Here if you see option B says 1 and 3 is correct, and therefore I wrote answer B, 1 and 3. Now question number 19. An iron nail is added to each of the two test tubes P and Q containing aqueous copper sulfate solution and aqueous silver nitrate respectively. Which of the following observation is correct? So here in the question they have given iron nail, that is Fe. The nail is made up of Fe, iron, is added to each of the test tube 2. So we have two test tubes P and Q containing copper sulfate, aqueous solution of copper sulfate. So we are going to take two test tubes in which it is containing aqueous copper sulfate solution CuSO4, and in one test tube there is the aqueous silver nitrate solution, that is AgNO3. So respectively means P test tube containing aqueous copper sulfate solution and Q test tube containing silver nitrate solution. Then which of the following observation is correct? So we have to see the test tube, we have to observe the test tube, and then we have to tell which observation is correct. Now see option A. In test tube P, iron nail is coated with a blue coating. After some time, iron nail will get coated with the blue coating, and test tube Q there is no reaction. Then option B is iron nail is coated with brown coating in test tube P and silver coating in test tube Q. Then option C is there is no reaction in either test tube P or Q. Means in P and Q, both the test tube there will be no reaction. And option D is there is no reaction in test tube P, but a silver coating on iron nail is seen in test tube Q. So these are the four observations they have given. We have to write the correct observation from this. So this is the example of actually displacement reaction. So here in displacement reaction, if you see, the more active metal or the element or species will replace the less active species. So here same concept we are going to apply, and for that we should know which is more active and which is less active species, and for that we should know the electrochemical series in which the elements will be arranged in the decreasing order of their reactivity. So let me write the electrochemical series here. So I will write it here, electrochemical series, which will help us to solve this question. So it is already given in the NCERT book. So I'll write it here, electrochemical series. So in this series, more active metal, that is potassium, comes first. After this, we will write sodium. Then we can write calcium. We will write Mg. Then we will write aluminium. Then comes zinc. After zinc, iron. Then there is a lead, that is Pb symbol, lead. Then comes copper. After this we have Ag, silver, and then we have gold. If you see, these all the elements are more active, or you can say reactive. And as we go down, the reactivity decreases. So here I'll write less active. So I hope you are understanding. As we go down, the activity or the reactivity decreases. So here I'll write reactivity decreases. So this series is called electrochemical series. By using this series, we can answer this question. So here I will write iron, and this we are going to add in two test tubes. So one test tube, that is, I will write here test tube and denoted by P, and this is containing copper sulfate, so CuSO4, and another test tube which is containing silver nitrate. The symbol denoted by this is Q, and it is containing silver nitrate, means the formula is what? Silver nitrate, it is AgNO3. So here this ion is going to react with copper sulfate in the first test tube, and it is going to react with silver nitrate in the second test tube. So we will write the reaction and we will see either it is going to replace or no. So Fe plus CuSO4. Now see what happens. Here we have to compare this iron with copper because these are the metals. So if you compare this iron and copper in the series, iron is here and copper is below. So which is more active? Iron is more active and copper is less active. So when this both comes in contact with each other, because iron is more active, I'll write it here. This is more active, copper less active. So now what happens when this both comes in contact, when iron is added to copper sulfate, iron will go and replace this copper. So what we'll get? We will get copper plus iron sulfate, FeSO4. So copper will come outside and this it will be replaced by Fe. So we will get FeSO4 and this is of which color? It is of brown color. So brown color. So here the iron nail is going to coat with brown color. Now we will see the second reaction. So I will take iron and this is going to react with silver nitrate. So I will take AgNO3. Now we have to again focus on the electrochemical series. So again iron is here itself and still silver is down. It is down than copper also. So copper and silver both are less reactive. If you see silver, it is less reactive than copper also. So we will write it here. Iron more active and this is less active. Now what happens again? Because iron is more active, it will go and replace this silver and therefore we are going to get silver plus again FeNO3 and here it is twice because we have to balance the oxidation state. Here we have to take twice and because this we will take here 2. That's why the whole reaction, this also we have to balance, so we have to take it 2 here also and because of that the 2 should be here also. This is called balance reaction. So this we will get silver separate. You can see here, this we are getting silver separate. So whatever nail is present in this Q test tube, here the nail will get coated with silver coating. So in P test tube, it is getting coated with brown color and in Q test tube, it is going to coat with silver coating. And now we have to see the options. If you see the option in the first test tube, P iron nail is coated with blue coating and in test tube Q there is no reaction it seems. So it is wrong. Then B iron nail is coated with brown coating and silver coating in Q. So this option is the correct one. Now no need to check the C and D option. Therefore, the correct option is option D. So write down answer B, that is iron nail is coated with brown coating in test tube P and silver coating in test tube D. I hope you understood this answer. Now we'll move with next question. Now question number 20. Methyl orange is added to dilute hydrochloric acid and to aqueous sodium hydroxide. What is the color of the methyl orange in each solution? So here we have to write the answer for this question. It is not a multiple choice question. So directly we have to write the answer for this. So if you see this is a methyl orange. It is nothing but acid base indicator. So methyl orange, it is a acid base indicator. There are many type of indicators. Acid base indicator, then we have metal ion indicator, then we have redox indicator, etc. So methyl orange is an acid base indicator, means it is used to check the solution is acid or the solution is base by observing the change in the color. So here this methyl orange we are going to add to dilute hydrochloric acid as well as in aqueous sodium hydroxide, and we have to tell what is the change in the color. So whenever methyl orange indicator, it is originally little bit of orange in color, reddish orange in color, and when it is added in a dilute hydrochloric acid, which is an acidic solution, it becomes orange red in color. So remember, already the methyl orange original color is little bit of reddish, but once it is added in acidic solution, it becomes orange red in color. So little bit color change will occur when it is added in acid. But when it is added in base, sodium hydroxide is nothing but a basic solution, or it is also called as alkaline solution. When it is added in base, alkaline solution, it changes its color to yellow. Whole solution will get yellow color. So if your solution is getting yellow by adding methyl orange indicator, then the solution is base. If your solution is giving orange red color, little bit change in the color when it is added, when this methyl orange is added, then the solution is base. Sorry, the solution is acid. I'll repeat once again. Methyl orange indicator becomes orange red when it is added in acids. Methyl orange indicator becomes yellow when it is added in base. So this is the answer for question 20. Now we will move with question number 21. Question number 21 is, which of the following substances when dissolved in equal volume of water will have the highest pH value? So here they have given some of the chemicals like sulfuric acid, acetic acid, magnesium hydroxide and sodium hydroxide. So if you see this, A and B both are acids and C and D both are bases. Sulfuric acid, a strong acid, acetic acid, a weak acid, magnesium hydroxide, a weak base, and sodium hydroxide, a strong base. Out of these four, which one, when dissolved in equal volume of water, will have the highest pH value? That we have to tell. So the answer is, first you should remember, the substance that will give highest pH will be always a strongest base. We know the pH scale. What is pH scale? So here I will write pH scale. These everything I have explained in acid, base and salt chapter. If you have not watched my video, go through my channel and watch the full chapter, that is acid, base and salts. There I have explained this completely. So in pH scale, if you see, it starts from 0 till 14 and somewhere middle there will be 7. So 0 to 7 till 7 it is acidic. This is acidic. And here it is neutral. Exactly 7 pH means it is neutral, and from 7 to 14 this is basic. So I hope you are understanding. So here 0 to 7 till 7, 6.9 it is acidic, 7.1 to 14 it is basic, and 7 is neutral. In this 0 to 7 which is acidic, 0 means it is highly acidic. This you should remember, highly acidic. And 6.9 means this is less acidic. This everything I have explained in my video which I have already uploaded. Go through my channel, you will understand everything. Then from 7 to 14, here 7, this is nothing but less basic. Less basic means from 7 it is going to start to convert into basic, therefore it is less basic. And this 14 means it is highly basic. So according to this pH scale, if you see the statement, the base substance that will give highest pH will be strongest base, correct? This is the highest pH. You can see 14 is the highest. So if your solution is giving 14, 13 or 12, then it will be a strongest base, that is highly basic. Now if you see again answer, the substance that will give the highest pH is the strongest base. Remember this statement and then we will solve. So what is sulfuric acid? Sulfuric acid, it is nothing but H2SO4. It is a strong acid. Whenever H2SO4 is added into the water, all H2SO4, whole H2SO4, all the H2SO4 molecules will split to give H plus and SO4 minus 2. Now to balance here I have to take 2H plus. Means whatever amount of H2SO4 we will take, all H2SO4 will dissolve. It splits to give more number of H plus and SO4 minus 2. Because of more number of H plus, the pH value becomes less. pH value will be decreased. It will become 0, 1 or 2. But in the question they have told highest pH. And that's why this cannot be the correct one. I hope you are understanding. Acids will be always have pH from 0 to 7. And whichever is strong acid will have pH between nearby 0, 1, 2, and in the question they have told highest, so this cannot be the correct one. If you see acetic acid, the formula is CH3COOH. This, when it is added in water, it will also split to give CH3COO minus and H plus. But because it is a weak acid, all CH3COOH molecules will not split to give H plus, means you will have less H plus, less H plus, and because of less H plus, it will be a weak acid. So acetic acid is a weak acid, and because weak acid, it will have pH somewhere 4, 5, 6. So this also will not be the correct one, because in question they have told highest pH. Highest means somewhere near to 12, 13, 14. Now if you go for magnesium hydroxide, it is a base, MgOH twice. It is a base because once it splits, when it is added in water, it becomes Mg plus 2 plus 2OH minus. It gives OH minus. But because it is a weak base, it will not give more OH minus. It gives less OH minus. Less OH minus means what? It is less basic. So its pH will be somewhere near 8, 9, 10, like this. So in question, as I told, it is highest pH. Now we will focus on the next one. Sodium hydroxide, that is NaOH. And this is a strong base because when it is added in water, all NaOH molecule will split to give Na plus and OH minus. All NaOH molecule. Therefore, whatever OH minus ions we will have, those will be more in number. And because OH minus are more, they will be highly basic, and because highly basic means the pH value will be highest, somewhere 13 or 14. According to the question, this will be the exact match for this question. As I'll be telling, MgOH twice, magnesium hydroxide, this is also base. Sodium hydroxide also base, but magnesium hydroxide is weak base. Its pH will be somewhere between 7, 8, 9 and 10. But if you see sodium hydroxide, its pH will be somewhere 13 and 14. So this will match to our question, and therefore option D is the correct. Sodium hydroxide, strong base, fully dissociates in water. So D, sodium hydroxide. This is the explanation of this question number 21. For detailed explanation, you go through my channel and watch full video of acid, base and salts chapter. You will understand everything basic of this chapter. So after this, we are going to move with next question. Now the next, that is question number 22. When excess of carbon dioxide is passed through lime water, the milkiness disappears because, so this is again a 1 mark question. So here we have 4 options. So when carbon dioxide, CO2, is passed through lime water is nothing but calcium hydroxide, CaOH twice. So when this CO2 is added to lime water, the milkiness will disappear, and that is due to what? What is the reason that we have to tell? So option A, water soluble calcium carbonate converts to water soluble calcium bicarbonate. Second one is insoluble calcium carbonate converts to water soluble calcium bicarbonate. C, water soluble calcium carbonate converts to insoluble calcium bicarbonate. And D is insoluble calcium carbonate converts to insoluble calcium bicarbonate. So these are the 4 options which are given. Now answer we will see. When excess of CO2 is passed through lime water, so what happens, that we have to tell. This we have to see step by step. So first we will see, when we will pass carbon dioxide in lime water, what will happen? And then when excess of carbon dioxide is passed through lime water, then what will happen? So first one. First, milkiness appears due to formation of insoluble calcium carbonate. So whenever CO2 is passed through lime water, calcium carbonate is formed, and this is insoluble, which will not dissolve. It will remain as it is, and due to this we can see the formation of milkiness into the lime water. So that can be shown by the following reaction. So what we have to do, we have to take calcium dioxide, or we can say carbon dioxide, and this we are going to pass in a lime water. Lime water means calcium hydroxide, that is CaOH twice. And when this CO2 effervescence are passed in this calcium hydroxide, this will form calcium carbonate, and this will be insoluble. So this downside arrow shows it is insoluble, and with this it will form water. So that is H2O. So whatever this calcium carbonate will form, this will give milkiness to the lime water. So this is the first reaction takes place when CO2 is passed to lime water. So this CO2 is little bit, it is not excess. Little CO2 when it is passed to lime water, we will get milkiness. Now suppose in the same solution of this milkiness lime water, if we supply excess of CO2, then what will happen? That now we have to see it here. With excess of CO2, this insoluble CaCO3, which is here, this insoluble CaCO3 reacts further to form water soluble calcium bicarbonate. So whatever CaCO3 it has formed which is insoluble, in this if we supply excess of CO2, it will further react to give calcium bicarbonate, and it is water soluble. So the milkiness disappears. So I hope you are understanding. So this we can show by the following reaction. So now what we have in the test tube, we have calcium carbonate which is insoluble, or I can write here milkiness, which is giving milkiness due to insoluble. So that also I'll write it here, insoluble. If we add excess of CO2 in presence of the water which has formed in the above reaction, you can see here, this will give calcium bicarbonate. So that is CaHCO3 twice. And this calcium bicarbonate is soluble. This is soluble. So once this whole gets soluble, dissolves, the water will become clear. So earlier it was little bit of milkiness, whitish, but after passing excess of CO2, it became soluble or clear. Now we can check our options. So in the option, water soluble calcium carbonate converts. Water soluble calcium carbonate, it is not soluble. So this is wrong. Option B, insoluble calcium carbonate converts to water soluble calcium bicarbonate. This is the correct answer. Now if I want to see the C and D also, water soluble calcium carbonate, it is not water soluble. Insoluble calcium carbonate converts into insoluble. So your calcium bicarbonate is not insoluble. So therefore this is also wrong. So therefore the correct answer is option B. Here I will write the answer. So I'll write answer, that is option B. And in front of that we should write insoluble calcium carbonate, that is CaCO3, converts to water soluble. So I'll write it here, water soluble calcium bicarbonate, CaHCO3 twice. So this is our answer for question number 22. Now we'll move to the next question. Now question number 23, in the reaction of aqueous solution of barium chloride. So barium chloride means BaCl2. It is aqueous with aqueous solution of sodium sulfate. Sodium sulfate is nothing but Na2SO4. So this both the aqueous solution, if we mix each other, if we react each other, then the aqueous solution formed will be, then in the product, which will be the aqueous solution? Aqueous solution means what? The substance which is completely dissolved in the water, that is called as aqueous solution. So here the options are A BaCl2, B BaSO4, C Na2SO4, and D is NaCl. Now we will see the answer of this. If you see the option, our reactant is, one is barium chloride and the another one is sodium sulfate. What is barium chloride? The formula is BaCl2, and the another one is sodium sulfate, that is Na2SO4. Then if these are the reactant, then product cannot be BaCl2, so therefore A option will be wrong. Again, product cannot be Na2SO4, this is also wrong. So now the remaining option is option B and option D. Out of these two, whichever is correct, that we have to answer. So see the answer. When aqueous barium chloride reacts with aqueous sodium sulfate, double displacement reaction occurs. Double displacement reaction means what? Both, all the ions will get exchanged. Now see here, BaCl2 reacts with Na2SO4. So this is AQ. AQ is explaining the state of the solution. State is aqueous. So here AQ. So BaCl2 plus Na2SO4, when it combines, now see, this Ba is positive, Cl is negative, Na is positive, SO4 is negative. So this positive combines with this negative and this negative combines with this positive. So what we are going to get? We are going to get BaSO4 and NaCl. But in these two products, BaSO4 is in the solid form. So this will give precipitate. I'll write it here, PPT. This will get precipitate, white color precipitate. And what about NaCl? NaCl is a sodium chloride salt which will be dissolved in the water. So this will dissolve in the water means what? It will form aqueous solution. And the question asks, the aqueous solution formed will be, so aqueous solution is our NaCl. Therefore, our correct answer is option D. So here BaSO4 is insoluble, forms white precipitate, and NaCl remains in the aqueous solution. So therefore, correct answer is option D. So this is the answer for question number 23. After this, we will see the next question. Now the next question, we are going to see question number 24, and it is having assertion and reason. It is again carrying 1 mark. So first we will read the question. The following question consists of two statements, assertion and reason. Answer these questions by selecting the appropriate option given below. So we have here 4 options. A says both assertion and reason are true, and reason is the correct explanation of assertion. B says both assertion and reason are true and reason is not the correct explanation of assertion. And C says A is true but R is false. Means reason is true but assertion is true but reason is false. D says assertion is false but reason is true. So by seeing this assertion and reason and their relation, we have to choose the correct option from this. So we will see the question number 24. Assertion is C4H8, C4H6 and C4H10 are members of the same homologous series. They are saying these all 3 members are of same homologous series, and the reason is C4H8, C4H6, C3H4, C3H6, C2H4, C2H2 are unsaturated hydrocarbons. So here now we have to first check these both are true or no, and then we have to see these are both are related or no. Means the reason is correct explanation of assertion or no. So what is homologous series? Homologous series means the series in which all the compounds will have the difference of CH2 group in those. The successive member of these all homologous series should have the difference of CH2. That is the main explanation of homologous series. Now if I see our compounds, one is C4H8, second one is C4H6, the next is C4H10. If you focus these all the 3 compounds, see the difference between these two. There should be the difference of CH2 group. 1 carbon should be extra and 2 hydrogen should be extra. If you focus, there is a difference of 2 hydrogen, but carbon is same. You can see here, carbon is C4. And even in these two, if you see, again there is same carbon, that is C4. So here only the main reason of being homologous, compound of homologous series will be cancelled. And therefore, assertion is completely wrong. If I want to tell you in detail, C4H8, it is nothing but what? You can see here, I will take 4 and then I have to adjust 8 hydrogen. So 1 here, 1 here, 1 here, 1 here. I will adjust 1 here, 1 here, 1 here, 1, 2, 3, 4, 5, 6, 7 and this is 8. So all 8 hydrogen had got finished. Then this carbon will be having lack of hydrogen. Therefore, I will put here double bond. Then here 1, 2, 3, 4, 5, 6, 7 and 8. So again this should have So here I cannot take the bond because already it has a bond, so I'll remove this bond. I will put a double bond now and then I'll put a single bond here. So now it is correct. So it is nothing but what? It is having double bond means it is alkene. It is alkene. And last one, if you see C4H10, it is alkane because it is H10. And if you see this one, it is alkyne. So these all are the members of different homologous series. This can form alkane is the member of alkane homologous series. Alkane is nothing but what? This is butane. So here I will write. So this is butane and this is butene and this is butane. I hope you know how to label name these all. So butane is the homologous member or it is a member of alkane homologous series here. Then butylene, it is a member of alkyne homologous series. Butene, it is a member of alkene homologous series. These cannot be the members of same homologous series. Therefore, assertion is false. So this is false. We understood assertion is false. Now we will come to reason. Reason they have told C4H8, these all the members are unsaturated hydrocarbons. Unsaturated means what? The hydrocarbon, either they should have double bond between the carbon atoms, two carbon atoms, or they should have triple bond between the two carbon atoms. Either double or the triple bond. Those hydrocarbons are called unsaturated. If they have single bond, then it is called saturated. Now if you see, just now I have drawn here one C4H8. So this is C4H8. It has a double bond, so it is unsaturated. It is correct. Now next I will draw for C4H6. So I will take 4 carbons and 6 hydrogens means 2 again I have to remove. So what I should do here? So C3, 1, 2, 1, 2, 3, 4, 5, 6. Done. So here I will put double bond. Here, sorry, I cannot put double bond here. So I will remove. Here I will put double and then I will put triple. Now let me see carbon valence is balanced or no. This carbon has 4 bond, this carbon has 4 bond, this carbon has 4 bond, this is also having 4 bond. So what is this? This is having a triple bond. So this is also unsaturated, this is also unsaturated. Now come to this C3H4. So let me draw here C3H4. So C3 I will take and H I should take only 4. So 1, 2, I will write it here 3 and then I'll write it here 1, 4 over. Now see this carbon should have one bond here. This carbon I will write 3 bonds. So valence check, balance, balance, balance. So this is also unsaturated. C3H6 means what? C3H6 means I have to increase another 2 hydrogens. So I should not take triple bond, I should take double bond. So I took here double bonds here. Then like this H, H, H. I hope you're understanding. Each carbon should have 4 bonds. So that carbon valence will be balanced. 1, 2, 3, 4, 5, 6. So this is also alkene, so unsaturated. Now see next one C2H4. C2H4. Very easy. C2H4. 1, 2, 3, 4. So each carbon require 2 bonds. So I'll write it here 2 bonds. So this is also unsaturated. And the last one C2H2. It is ethene. So it's not ethene, it is ethine. So I will write the structure of this. So C and C, only 2 hydrogens. So like this. So how many here bond? There should be 3 bonds. So it is alkyne, ethine. So this is also unsaturated. So reason is true. Assertion is false, but reason is true. But there is no relation between the assertion and the reason. Means reason is not the correct explanation of this assertion. So here I can write like this. So assertion is false, but reason is true. If you see all the options, this will be the correct option. So answer is option D. Assertion is false and reason is true. So this is the answer for this question number 24. Now I will move to the next one. So till here we have completed all 1 mark question. After this we will move with the 2 mark question. So I hope you are understanding all the answers of these all the questions. If you have any doubts or Anything related to these all the questions, you can comment those all the doubts in my videos. So in 2 marks, question number 25, we will start. The following activity is set up in the science lab by the teacher. He clamped an aluminium wire on a stand and fixed a pin to the free end of the wire using wax. So you can see in the diagram here, this is the clamp, this is the stand, and this is the metal aluminium wire, and to this aluminium wire, this is the fixed end and this is the free end. To this free end, here there is a wax, and through this to this wax there is a pin which is attached. So this is pin and this is waxed. Now then he heated the wire with a burner from the end where the wire is clamped. So where the wire is clamped here. So he started heating this wire at the end where it is clamped. So here it is heating. See this flame. So here wire is heating from the end where wire is clamped. Students observe the pin fall off. So when the teacher started hitting this wire here, the pin which is on the free end, that will fall off. And depending on this whole observation, we have here two questions, question A and question B, that we have to answer. So question A is, if the teacher replaces aluminium wire by silver wire, will the student's observation changes? Justify your answer. So in the question A, if this aluminium wire is replaced by silver wire, then will the student's observation change? Means this pin falls due to the heating, that observation will change or no? If it is changes or if it is not changes, you have to justify your answer. Then question B is, will the aluminium wire melt? Give reason for your answer. Means this is the aluminium wire. Here we are heating. Because of the heating, this aluminium wire will melt or no? If it melts or if it does not melt, you have to give the reason for your answer. So we will see the answer for this question. So the answer is, this activity demonstrates transfer of heat by conduction in solids. So this activity is done to explain that solid conducts heat, that we have to explain. Aluminium is a good conductor of heat. When the aluminium wire is heated at the clamped end, heat reaches the wax, melts it, and the pin fall off. See, it is very simple. As we all know, solids are the good conductors of heat and electricity. So because of this reason, and in the solids, aluminium is a good conductor of heat. And because of this is the aluminium wire here. Our pin is here, which is connected with this aluminium wire with the help of this wax. When you heat this aluminium wire at the clamped end on this side, the heat will be transferred through this aluminium wire. The heat will be transferred like this. When this heat comes and reaches the wax will melt. When the wax melts, because of the wax, this pin is attached to this aluminum wire. And if the wax get melt, automatically the pin will fall off. So this is the thing that is explained in the answer. Now, if you see the question A, if the teacher replaces aluminum wire by silver wire, now we have to see the property, conduction of heat, how it changes when the metal is changed. If you see silver, silver is a better conductor of heat than aluminium. If you compare the conductivity property of silver and aluminium, both conducts heat. But if you compare, silver is the better conductor. So it conducts in a better way compared to aluminium. So heat will travel faster along the silver wire. As a result, wax will melt more quickly and the pin will fall off sooner. I hope you're understanding the answer. So what they have told here, imagine this is the aluminium wire and here there is a pin with the wax, and this is the silver wire and here there is a pin with the wax. Then if you compare the conduction, in silver it is faster. So in silver, if it is taking 1 minute to fall this pin, then in aluminium it takes something 5 minutes. Just imagine, roughly I am telling, it is taking 5 minutes. So aluminium is taking more time. Means the conduction of heat in aluminium is slow compared to the silver, because silver is the better conductor of heat. This is the explanation of the question A. And if the time is less, then pin will fall sooner. Now question B. Will aluminum wire melt? Give reason. Aluminum wire will not melt. So here the answer is no. The aluminum wire will not melt. Now we have to explain the reason for this. This is because aluminum has very high melting point. What is melting point? The temperature required to melt the metal. That is called as melting point. And aluminum has very high melting point, somewhere nearby 660 degrees Celsius. So till we heat 660 degrees Celsius, aluminum will not melt, which is higher than the temperature produced by the burner. Here in the activity we are using burner, and burner will not produce the heat, that is 660 degrees Celsius. And if it is not producing that much of heat, then there is no chance of this aluminum wire that is getting melted. And therefore the answer is aluminum wire will not melt, and the reason is because it has a high melting point, about 660 degrees Celsius, and burner will not produce such a high temperature of heat. So this is the answer for this question number 25. This question carries 2 marks. After this we are going to move with the next question. So this was one question in 2 mark. So in this 3 mark question, first one is question number 26. Attempt either option A or B. So in this question we have an internal choice. Here we are going to start with A, and on the next page we are going to start with B. Whenever such type of question comes, remember you have to attempt any one, either A or B. And how to choose which question to be solved? That is, you have to read the question, try to understand the question, and think that which question you can solve completely and correctly. Whichever question you are confident that you will solve completely and correctly, that question only you have to attempt. After solving A question, then again you cannot attempt B question. Any one question you have to attempt. So now here I am going to solve A first. An element X is stored in kerosene. So see here, there is the element X which is going to be stored in kerosene and cannot be extracted from its ore using reducing agent. X forms an ionic compound on reaction with chlorine. So this is the question, this is the statement which is given, and based on this statement now we are going to have the question. So here question number 1 is, can we store X in water? Give reason to support your answer. So first we have to find out what is X, and then we have to think, can we store that X, that element in water? If yes or if no, you have to give the reason for your answer. So the answer is no. You cannot store this element X in water. Element X cannot be stored in water. So what is that X? X is nothing but an element called sodium. This is an element called sodium. So what is the reason? It is highly reactive. So you maybe have seen the electrochemical series, the series in which all the elements are arranged in the decreasing order of reactivity. So if you see there, sodium and potassium comes on the top of the series. So here sodium will be more reactive or highly reactive and reacts violently with water. So as I told, sodium is highly reactive. When it is added in water, it reacts violently, producing heat and hydrogen gas. So it produces heat as well as formation of hydrogen gas, which may catch fire. So it can also catch fire. Hence, it is stored in kerosene to prevent contact with air and water. So this is the reason for question number 1. Now question 2, identify element X, name the process used and write the equation for the extraction of X from its ore. So what is the element? Just now I told the element is X is sodium. The symbol is Na. And the process used for extraction of this sodium is electrolysis. So here the sodium cannot be extracted by using reducing agent, and the reason for this again same, because it is highly reactive. You cannot add any chemicals to extract the sodium, because when you add any chemicals like reducing agent, because of its reactivity, it immediately react with the chemicals and it forms something else. And to avoid that, here we are going to use electrolysis process. What is electrolysis process? In this we are going to supply electric current and we are going to break the ore. Lysis means breaking. By supplying the electric current, we are going to break the ore and we are going to separate our sodium. So the process is electrolysis. And the reason for this is sodium is very reactive, cannot be extracted by using reducing agent. And what is the reaction for this? So this is our ore, that is sodium chloride, NaCl. When you add electric current, NaCl will get break and Cl will separate and Na will separate. So this is the Na is nothing but what? The sodium which you want to separate, and Cl2 it is the byproduct which are getting here. So in this electrolysis process, we are going to use electrodes. Electrodes nothing but are the metals which conduct electricity in solid state. So in one of the electrode, Cl2 gas will be formed, that is chlorine gas will be formed, and this again you can use for some other chemicals preparation. So this is the answer for question number 26. Now after this we are going to see the next, that is choice, which we have question B. So now we are going to see the OR option from this, which is also going to carry 3-mark question. So the statement given in question B is, the domes of many buildings in Europe are made of copper. So see the sentence. The domes of many buildings in Europe are made up of copper. These domes now appears greenish in color. So this is the statement given, and based on this statement we have 3 questions. Question 1, why do the domes appear greenish through copper, greenish though copper is orange red in color? So what is the color of copper? Copper color is orange red in color, but these domes appears greenish in color. So why? What is the reason that we have to answer? So the answer is, domes appear greenish because copper react with moist air. So copper, it is a metal which can react with the moisture or the gases present in the moisture to undergo corrosion. So these domes appear greenish because copper reacts with moist air, means which consists of oxygen, carbon dioxide, water vapors, to form green layer of basic copper carbonate. So this copper, when reacts with this all moisture, copper convert into copper carbonate. CuCO3 is nothing but copper carbonate, and this copper carbonate color is greenish in color. That is nothing but copper is undergoing corrosion to form copper carbonate, and because of this domes you can see greenish in color. Question number 2 is, in your opinion, should the copper domes be replaced by iron dome to overcome the problem of change of color of copper domes? So question number 2 is, if the copper domes are changing the color to greenish, then should we replace that copper with iron? Actually the answer is no, because even iron undergoes corrosion. So no, copper domes should not be replaced by iron domes. Iron rust easily. Now if you compare the corrosion power of copper and iron is very much reactive towards the moisture or the air. So if you compare the rate of corrosion of copper and iron, the rate of corrosion in case of iron is very high, and it rusts easily in presence of air and moisture, which weakens the structure. The structure of the dome gets weakened. It becomes weak. The green coating of copper actually protects it from the further corrosion, whereas rusting of iron causes continuous damage. This is very important sentence you have to remember. So let me explain this with the diagram. Imagine this is one metal piece and it is made up of iron, and this is another metal piece, it is made up of copper. Now when these both the metals comes in contact with the moisture, now what happens? Both are susceptible towards the moisture and both can undergo corrosion. So now what happens? When iron undergoes corrosion with this moisture, say oxygen gas from the moisture, so Fe react with the moisture and forms Fe2O3, iron oxide, brown color powder. And that brown color powder which is going to be formed, this will not remain attached on this metal piece. It will not remain attached like this on the metal piece. It will fall down immediately after the formation of this iron oxide powder. That all iron oxide powder will fall down here. It will not remain attached to the iron piece, and due to this what happens? once the first layer of the iron undergoes corrosion, then that will fall down as iron oxide. Then the second layer of iron atoms will undergoes corrosion, that will fall down as iron oxide. Then the third undergoes corrosion, and like this, corrosion will be continuous in case of iron. So it will destroy all iron metal. But in case of copper, if this is the first layer of copper atoms in this plate, and when this reacts with the moisture, that is oxygen, this will form copper carbonate, CuCO3. And whatever copper carbonate will be formed, that layer will remain attached on the plate itself. It will cover this copper plate, that copper carbonate which has been formed, it will cover this copper plate. It will not fall down. Remember, as in iron oxide, the powder is falling down. It will not fall down in case of copper. So due to this, what happens? Because of this blue color carbonate, so here this is the blue color is the copper carbonate. Because of this blue color copper carbonate, the copper which is present inside the second layer of the copper atom will not come in contact with the oxygen, and the further corrosion is avoided. So here remember, in case of copper, this further corrosion rate will be avoided. So we should not replace iron in place of copper just because of the greenish color. So this is the answer or the explanation for question 2. Now question 3 is, domes used to be made from thin sheet of metals. Why did the ancient architect use copper to make domes? So now answer is, ancient architect used copper because it is highly malleable. So it can be beaten into thin sheets. If you want to prepare a dome, then it should be very thin. It should be made up of a thin sheet. And to prepare thin sheet, any metal, what you have to do? You have to take a metal and you have to heat it. You have to heat the metal. And after heating this, when the metal will get soft, you have to beat this metal, and by beating you have to convert these metals into thin sheets, and this property is called as malleability. And copper is highly malleable, it can be easily converted into thin sheets by beating. Therefore this is the one of the important property copper is used to prepare domes. Second is resistant to corrosion, making it long lasting. So compared to iron, corrosion has the resistance, copper has the resistance to corrosion. As I told, if copper is undergoing corrosion, the outer layer will form this greenish color CuCO3, copper carbonate, but it will remain attached on the copper. Therefore further corrosion will be avoided and it will remain long lasting. So that is the next property reason. Third one is strong, durable, suitable for large structures like domes. So it is very strong metal, it is a durable, and it is suitable for large structures like domes. So these are the properties because of which ancient architects use copper to make domes. So this is the answer for question B. So question A is finished, question B is finished, whichever you feel easy that you have to attempt in the exam if such type of question comes. After this, we are going to move with the next question. So the next is question number 27. This also carries 3 marks. So we will read the question. Amrita electrolyzed distilled water using the setup shown in figure 1. So this is the figure 1 which is here, and by using this setup, Amrita has electrolyzed distilled water. Electrolyzed means by using electric current she has braked distilled water. What is the meaning of distilled water? The water which has very less amount of salts, negligible, which can be neglected, that is very less amount of salt, it is called as distilled water. She was expecting two gases to be evolved at the anode and cathode respectively. So when she did this electrolyze this by using distilled water, she thought that she is going to get two gases, one at the anode and one at the cathode. Suddenly she realized that the bulb in the circuit did not glow when she used distilled water. So when she started the experiment, she realized that the bulb which is connected into the electric circuit, you can see in the figure 2, electric circuit, it is not at all glowing. If this bulb is not glowing, the meaning is what? Your circuit is not complete. The current is not moving in the circuit. That is the meaning if the bulb is not glowing. And when she started the experiment, she realized the bulb is not glowing. After this realization, she added substance to the distilled water for electrolysis to take place. So once she realized that if the circuit is not complete, bulb is not glowing, electric current is not moving in the circuit, she added some substance to the distilled water. And due to that substance, then the bulb started glowing when she started the switch. Answer the following question based on the information. So by using this all the information, you have to answer the questions. So here we can see question number A. Which gas was she expecting to be formed at the anode and which one at the cathode respectively? So as the first sentence, she has used distilled water here, and by using distilled water, she is doing electrolysis. Distilled water, water means what? It is H2O. Water means it is H2O. And she is using this water and doing electrolysis. She is supplying the current and breaking the compound. So once she supply the electric current, this water will get break. And once the water will get break, you are going to get two elements, hydrogen and oxygen. So hydrogen, HH will combine to give hydrogen gas and OO will combine to give oxygen gas. So she can expect hydrogen gas and oxygen gas to the form towards the electrodes. Now, which gas will form towards the anode and which gas will form? So here, oxygen gas will be formed towards the anode and hydrogen gas will be formed towards the cathode, because oxygen we know it is giving ion O minus 2 when water will break. O minus 2, it is a negative ion. Negative ion will be attracted towards the positive electrode. Therefore, towards anode we get oxygen gas. And what is hydrogen ion? H plus. It is a positive ion which is attracted towards the negative electrode. Therefore, hydrogen gas will be formed towards the cathode. So this electrode is shown by negative sign. This electrode is shown by positive sign. So I hope you remember. The opposite charges will get attracted. Therefore, once the water is broken, it gives oxygen and hydrogen ions, O minus to H plus. So H plus will go to cathode, O minus 2 will go towards anode, and there hydrogen and oxygen gas will be formed. So this is the answer for question A. Now question B. Why did the bulb not glow when Amrita passed electricity through distilled water? Very simple. As I told, when she used distilled water, the bulb was not glowing. What is the reason for this? That you have to explain. The bulb did not glow because distilled water is very poor conductor of electricity, because it don't have any salts in it. Salts are not there means there will be no positive and no negative ions. If no ions in the water, then nobody will be there to pass the current, and therefore distilled water is a poor conductor of electricity. It contains almost no ions, so electric current cannot pass through it effectively, and therefore bulb not glow when Amrita passed electricity through distilled water. Then question C, which substance was added by Amrita to distill water to get expected result? So as I told, it don't have any substance to form ions. If you add any substance which gives ions, then the water can conduct electricity, and you know the ionic compound, that is salts. If you add any salts into the water, once you supply the electricity, salts will split into positive and a negative ion, that is cation and anion. For example, if you add NaCl, salt, sodium chloride, it will split into positive Na plus ion and negative Cl minus ion. And these negative and positive ions are responsible to pass the electric current, and therefore the answer is salt. So here even you can add, here you have to add some one few drops of sulfuric acid to form this reaction faster, to increase the rate of the reaction. So see here answer, Amrita added an electrolyte. Electrolyte is nothing but salts, typically a few drops of dilute sulfuric acid to the distilled water, so that ions present in the present and electrolysis takes place. So here you can add electrolytes such as dilute sulfuric acid. This is also one of the electrolyte. You can add any other salts also into the water, which forms ions, and these ions are responsible to pass the electricity. So this is the answer for question C. So here we have completed question A, B and C, which is asked in question number 27. So each question carries 1 mark. So total marks we are going to get from this question, it is 3. So whenever you solve such type of question, these figures will be given to you. You have to focus on the figures. You have to see the sentences, statement which are given, and match these both, relate these both, these statements and the diagrams, and then try to answer the questions. Remember, whenever such type of question comes, your whole answers will be there in the statement itself. Just find out those answers and write down for these questions. So here we have completed all 3-mark question from part B chemistry. After this we are going to start with 4-mark question. I hope you are understanding all the answers and explanation of this question. You can see my videos and like my videos, share my videos with your friends, and still if you are not subscribed my channel, please consider subscribing my channel. So as I told, we are going to solve 4-mark question. So here we have only one question in 4 mark, that is question number 28. To see it is little bit big, but just you have to read this statement carefully, then it will be easy to answer all the questions. So Sarah took 2 ml of dilute NaOH. So Sarah, she has took one test tube, and in that she has took 2 ml of dilute NaOH solution. What is NaOH? NaOH is a base, sodium hydroxide. So it is a basic solution. She has took basic solution 2 ml in a test tube and added 2 drops of phenolphthalein solution to it. What is this phenolphthalein? It is an indicator, which is a type of acid base indicator. So the indicator which is used to find the given solution is acid or base by changing its color. Such type of indicators are called acid base indicator. And phenolphthalein is one of the common acid base indicator which gives pink color in base and remains colorless in acid. So now, so what she did, she took basic solution 2 ml in a test tube and added 2 drops of phenolphthalein. So as I told, it is added in base, it should give pink color. So the solution turned pink in color. She added dilute H2SO4 to the above solution. Now the solution is already pink in color because of the base, and now she is adding H2SO4 to this solution drop by drop. When you add acid to the base, it neutralizes the base. Acid will neutralize the base and try to decrease its basic properties. So now what happens? When this is added drop by drop until the solution in the test tube becomes colorless. So once you add this H2SO4 drop by drop, the basic property will be go on decreasing, and therefore pink color will become light and light, and at some stage the pink color will goes and the whole solution becomes colorless. Now what is the meaning of this? All this acid which are added, it has neutralized this base and forms salt. Now 40 drops of dilute H2SO4 were used for the change in color from pink to colorless. So here, as I told, H2SO4 is added drop by drop. How many drops were required? 40 drops of H2SO4 required to neutralize this 2 ml of NaOH. Now next, when Sarah added a drop of NaOH to this solution, now see, it was 2 ml of NaOH, we added 40 drops of H2SO4, it got neutralized. Now it is colorless. And now Sarah will add a drop of NaOH again. And now the color will be, now it is becomes basic, and now the color will again change back to pink. Sarah now tried the activity with different volumes of NaOH and recorded the observation in the table given below. Now she did the same activity by using different volumes of NaOH. In the statement she has used 2 ml, but by changing this volume of NaOH she did the same activity. And whatever reading she got, that all she has recorded into this table. So you can see, first she took 2 ml and drops of H2SO4 required 20. Then she took 3 ml NaOH, drops of H2SO4 used 30. She took 4 ml NaOH, drops of H2SO4 required 40. So remember, NaOH is in ml and H2SO4 is in drops. This you have to remember. Now, answer the following question based on the above information. So by using this activity and using this table, you have to answer the given questions. Question number A is, if Sarah used concentrated H2SO4 in place of dilute H2SO4, how many drops will be required for the change in color to be observed? So here you can see, first she took 2 ml of NaOH and she added dilute H2SO4 drop by drop, and the color became pink to colorless because you are adding acid. But this acid is dilute. Dilute means what? There is a water in this. So because of the presence of water in this H2SO4, H plus ions will be less in a dilute H2SO4. I hope you are understanding. Whenever we say dilute, the H plus concentration will be less because of the addition of water. And these H plus are responsible to change the color from pink to colorless. Because it is dilute, it has less H plus, and therefore it gets 40 drops to change the color from pink to colorless. But in the question they are saying it is concentrated. If we add concentrated H2SO4, so concentrated means what? H plus ions will be more. If H plus ions increase, automatically the change in color will take place soon, easily or faster, and you required less amount of H2SO4. If you compare the H plus ion in dilute H2SO4 and concentrated, more amount of H plus ions will be there in the concentrated, and H plus ions are responsible to change in the color. If you add concentrated, then very easily in less drops color will change, and that's why the option you can see here, A is 40, B it is less than 40, C more than 40, and then you have to justify your answer. So what is the answer? We require less than 40 drops, because for dilute H2SO4 we require 40 drops. In concentrated we have more H plus, and therefore we require less than 40 drops of H2SO4. Now what is the justification? Same thing which I have explained. Concentrated H2SO4 contains higher amount of acid per drop compared to dilute H2SO4. Therefore, fewer drops of concentrated acid are needed to neutralize same amount of NaOH. Here they have not changed the amount of NaOH, and amount of NaOH is same, that is 2 ml. Only we are changing concentrated H2SO4 in place of dilute, and therefore as a result the pink color of a phenolphthalein will turn colorless in less than 40 drops. So this is the justification of this question A. So I hope you understood this question, that is A. After this we will move with B. Now we will see question B. Sarah measured 20 drops of dilute H2SO4 and found its volume to be 1 ml. So Sarah has measured 20 drops of dilute H2SO4 and she calculated in ml, so it became 1 ml. If Sarah observed a change in color of NaOH solution by using 3 ml of H2SO4, how many ml of NaOH did she added to the test tube initially? So if 20 drops of H2SO4 is nothing but 1 ml, then NaOH solution by using 3 ml of H2SO4, how many ml of NaOH did she added to the tube initially? So this is the question. What is the answer for this? 20 drops of dilute H2SO4 means how much? She measured 1 ml. Therefore, 1 drop is equals to how much ml? If 20 drops is 1 ml, then 1 drop is how much? So if you cross multiply, for 1 drop, it will be 1 by 20 ml. I hope you are understanding this. So 1 by 20 means how much if you calculate? If you divide 1 by 20, it is 0.05 ml. So this will be in ml for 1 drop. So remember, 20 drops means 1 ml, then 1 drop means 0.05 ml. Now, in the question, Sarah used 3 ml of H2SO4 to neutralize NaOH solution. We need to find the volume of NaOH solution initially added. So, how much NaOH was added initially, that we have to find out. So, by using this, now we will start. So, we will start solve in steps. So, 1. Determine the number of drops in 3 ml H2SO4. So, first we will determine the number of drops, because this everything is given in terms of drops. So, first we will find out how many drops are there in 3 ml of H2SO4. So, number of drops is equals to volume divided by volume per drop. Total volume divided by volume per drop. So what is the volume of H2SO4? It is 3 ml. So I took here 3. And volume per drop means single drop means how much volume? 0.05. So we divided it. Once you divide 3 by 0.05, we will get an answer 60 drops. So in 3 ml, how many drops will form? 60 drops will be formed. So 60 drops of H2SO4 neutralize the NaOH. We have converted our 3 ml of H2SO4 into drops and we have got the answer 60 drops. If you ask me to do this calculation, how you have divided 3 by 0.05, that also I can do it here. So see here, 3 ml divided by 0.05 ml per drop. You should remember or you should understand how to solve this whenever the numbers will be there in decimal. So what you have to do, it will be easy, the calculation will be easy if you remove this decimal. So remove this decimal and you have to, while removing, you have to send this decimal to the two places. So from 1, 2, the decimal should come here. So how many times you have moved this? 2 times. 1, 2. Therefore, we have to multiply 100 on the numerator and therefore it becomes 3 into 100. Why 100? Because we have moved our decimal to the second place here. 1, 2. Therefore, we have to multiply by 100, but it will be on the numerator. And down, now it will be only 5 because we have removed the decimal. Once the decimal comes here, there will be no meaning of this. It will be like 5.00. 5.00 is nothing but 5 only. Therefore, 5. Now see what happens. It will become 300 divided by 5. And now it is easy to divide. 5 ones are 5. 5 6 are 30. 5 zeros are 0. And we got our answer 60. So this is the 60 drops which we got. Now here we have converted our 3 ml of H2SO4 into drops. Now we will do the second step. So see the second step from the question. Now see what is the question. Sarah added 2 ml of NaOH solution initially. Initially Sarah has added 2 ml of NaOH and it took 40 drops of dilute H2SO4. We have seen in the question. Sarah, she has added 2 ml of NaOH and to neutralize that we took 40 drops of H2SO4. This gives us a ratio of H2SO4 to NaOH. So what we can do? We can do like this. H2SO4 drops is to NaOH ml. So what is the ratio? H2SO4 drops how many? 40. And ml how much we took? 2. So 40 is to 2. 40 is to 2. 40 drops for 2 ml. Then 20 drops for 1 ml we can write. So therefore it can be 20 is to 1. Now the third step. Now she used 3 ml of H2SO4 which is 60 drops. See here, she has used 3 ml of H2SO4 which is 60 drops. Let the initial volume of NaOH be VML because we don't know the volume. We have to find out this V. So again use the ratio H2SO4 drops divided by volume of NaOH. So what is the H2SO4 drop? 20 from the earlier, see here, 20. You can take 40 also, but we have used this one, 20. And what is the volume here? In ml, it is 1. So 20 divided by 1. Now, what is our given values? 3 ml, 60 drops. So I took 60 drops divided by, we don't know the ml, so therefore I wrote here V for NaOH. And this is the given, which is here. And now if you compare these two, so 60 divided by V, it is nothing but 20 divided by 1. Now what we can do? We can do cross multiplication. What will happen? 60 is equals to 20V. Now shift this V on this side. So it will become 60 divided by 20 is equals to V. And now if you divide 21s are 20, 23s are 60. So V will be is equals to 3 ml. And this is the answer. So here I have written V is equals to 3 ml. So initial NaOH solution added is 3 ml. And this is the answer for this question B. I hope you understood this answer. Try to understand each and every step. Here what I have done, I have divided this whole sum into 3 steps. Step 1, step 2 and step 3. It is little bit tough to solve, little bit confused, but try to solve it step by step. It will be easy. So this is the answer for question B. Now after this we are going to see the next one. In this question B we have an option or there is one more, we have C. So we can either you solve B or you can solve C. Now after this we are going to solve with the next option, that is C. Now the question is, that is or Sarah takes 10 drops of dilute H2SO4 in the test tube. Now she is going to take 10 drops of dilute H2SO4. So remember, it is dilute, means it has less H plus, but it is an acid. drops of H2SO4 in a test tube and adds drop by drop phenolphthalein indicator or solution to it. So phenolphthalein is the acid base indicator. She is going to add drop by drop into this H2SO4. Now remember, H2SO4 is acid and you are adding this indicator. So what color it should give? It should remain colorless. Now we are going to answer this all. Then she adds NaOH drop wise. Sarah observed a change in color after adding 20 drops of NaOH. What change in color would she observe and why? So very simple. Sarah's solution initially turns colorless because it is acid, and in acid phenolphthalein will be always colorless. So you have to remember one thing. So remember this, whenever there will be acid, if you add phenolphthalein, it will be colorless. This is the main thing which you have to remember and which is already there in the textbook, and already I have uploaded the video of this chapter, that is acid, base and salts. You can go through my channel and observe this whole chapter I have uploaded, and in detail I have explained this everything. So in acid, if you add phenolphthalein, it will be colorless. In base, if you add phenolphthalein, it will be pink color. So this you have to remember first. If you know this, then you can answer such type of any question if it is coming in the exam. So this you have to remember. So make a note of this in your book. Now come to the answer. Sarah's solution initially turns colorless because initially it is H2SO4 acid, and in acid if you add indicator it will be colorless, therefore colorless. In acidic H2SO4, as she adds NaOH drop by drop, so slowly one by one drop, if you add NaOH, this NaOH goes and neutralize this H2SO4. So what this NaOH is doing? The acidic property, it is decreasing slowly. It gradually neutralizes the acid, and after 20 drops, immediately it will not change the color because it is slowly neutralizing. After 20 drops, the solution becomes slightly basic. Why slightly basic? Because all H2SO4, all H plus have been neutralized, and now the solution is basic because of NaOH, extra NaOH. And if it is basic, what color it should give? It should give pink. So causing phenolphthalein to turn pink. This color change happens because phenolphthalein is colorless in acid and pink in base. This is the reason. So here I have explained answer and why. The reason of this is here in the last sentence. So this is the answer for this OR question. So I hope you understood this answer. Now this was the OR for question B. Now we will see the next option, that is C. Now here C we will see C option, which is very easy. Write a balanced chemical equation for the reaction taking place in the above experiment. Which of the following is true and why the reaction is? So here they have given 4 statements. You have to see which statement is true for the above reaction. So the statements are neutralization and double displacement, neutralization and precipitation, precipitation and double displacement, neutralization, double displacement as well as precipitation. So here first we will write the reaction of this. So you can see the reaction, we are using H2SO4 and NaOH. So it is acid, it is base. See what happens now. So if I take here H2SO4 and if I add this in NaOH, neutralization reaction takes place because acid will neutralize the base and base will neutralize the acid. So here hydrogen is positive ion, sulfate is a negative ion, Na is positive, OH is negative. OH means hydroxide. So positive of this will combine with the negative of this, negative of this will combine with the positive of this. So what we are going to get? We are going to get Na2SO4. And why this Na2SO4? This everything is already we have studied in the 9th standard. Depending on the oxidation state, we have to write this formula. So Na2SO4, and we are going to get water because when this H and this OH combines, we'll get water. We have to whole reaction we have to balance. So Na2 means here there should be 2, and to balance what hydrogen we have to take it here 2. And in such way we are going to get this chemical equation. So it should be balanced because in the question they have asked balanced chemical equation. So you have to write like this. Now this is salt and this is water. Whenever acid base react to give salt and water, such type of reactions are called neutralization reaction. So here it is clear that the reaction is neutralization. In the product if you see, water is the water medium And salt, sodium sulfate, it is aqueous salt. It can be easily dissolved in the water. It will not form any precipitate. So here there will be no precipitation. So second statement will go wrong. There will be no precipitation. Even the D will go wrong. There will be no precipitation. Then we have to check in A and C. C again having precipitation, so this will be wrong. So correct option is what? A. So in A they have told neutralization double displacement. What is double displacement? Displacement means changing the place. Double means all the ions will change the place. Positive of this, negative of this, positive of this, negative of this. Everything, all the places will change. That is called double. So here the reaction is neutralization and double displacement. So you can see the H plus which was here, it is going this side, and the Na which was here, it is coming this side. So all positive cation anions will change the place, therefore it is double displacement. For example, I am telling here, see, it is Fe, and if it is CuSO4, now what happens, see, only Fe will go on the other side and Cu will come out. So only one place will be changed. So it is a single displacement reaction. But if such thing happens, it is called as double displacement reaction. So the reason is acid reacts with base to form a salt and water, which is called neutralization, and involves cation and anion exchange. So it is called as double displacement, and there will be no precipitate formation. Precipitate means solid, PPT, solid formation. So there will be no solid formation, and therefore the correct option is here option A, and this is the reason for this question. So I hope you will understand all the answers I have explained very neatly and completely. Make a note of these all the answers. After this, we are going to solve with 5-mark question. So now we are going to start with 5 marks question, and in this question number 29, attempt either option A or B. Again, in this question we have an internal choice. Either you can answer A or you can answer B, whichever you feel easy that you can solve completely. Whichever you have a confidence that you will get a maximum mark, that you have to attempt. So we will start with question A. A hydrocarbon with the formula CXHY. So here they have given a hydrocarbon, but they have not told it is which hydrocarbon. So CXHY undergoes complete combustion as shown in the following equation. So you can see this equation. C6Hy, combustion means reaction with oxygen, and it is giving CO2 and H2O. So this is a combustion reaction of this hydrocarbon. Based on this reaction, we have to answer these all the question. Question 1. What are the values of X and Y? Give the chemical, that is IUPAC, name of this hydrocarbon. Draw its electron dot structure. Name the alcohol which on heating with concentrated H2SO4 will produce above hydrocarbon. And then write the balanced chemical equation for the reaction of this hydrocarbon with hydrogen gas in presence of nickel. So very simple questions which all are related to this reaction. So now such type of question, you have to read the textbook. Actually these all questions are from the textbook itself, but the asking pattern is little bit different. So if you read the textbook chapter from your textbook, then such type of questions answering will be very easy. So we will start the answer. Question number 1. What are the values of X and Y? Now see the reaction. In the reaction, whole reaction is balanced. The number of elements present, atoms present on left hand side is equal to the number of atoms present on the right hand side. So by using this concept, we can solve easily. So we have to compare first. First go for carbon. So we will compare the carbons. So see carbons how many? Here it is 2CX. This whatever 2 is there, this 2 is applicable to this carbon as well as hydrogen. So how many carbon here? 2CX on the left hand side, and the right hand side how many? 6 carbon. So if you have on LHS side 2CX and on RHS side if the carbon are 6, then same number of carbon should be there on the left hand side also. So see how many carbon on the left hand side? 2 into x, it is 2x, is equals to how many carbon on the right hand side? It is 6C. So it is 6. And therefore I have written here 2x is equals to 6. We have to compare it. To find out this x, 2 we have to shift on this side. So shift this 2 on the other side. It becomes x is equals to 6 divided by 2 and x is equals to 3. And by doing this, we got answer that is X is equals to 3. Same way we have to find out Y. Now see in the reaction, it is HY, but this 2 is applicable to hydrogen also. So therefore it will be 2HY, or you can say 2Y. And this side hydrogens how many? 6 into 2, it will be 12. So therefore 2Y is equals to 6 into 2. So 2Y is equals to 12. See there. Then 2 if you shift this side, then Y is equals to 12 divided by 2. And therefore Y will be how much? 2 ones are 2, 2 6s are 12. So Y is equals to 6. So we got X and Y. So first question is completed. Now therefore the formula will be C3H6. Now we are going to move with the second one. Write the chemical or IUPAC name of this. So the name is propene. It is propene. How to find out this? Now see. Like this we have to write the structure first. So C3, H how many we have? We have 6H. 1, 2, 3, 4, 5 and 6. So here hydrogen 6 completed, exactly correctly arranged. But have you balanced the valency of carbon? This carbon has 4 bonds, this carbon has 4 bonds, but this carbon has only 2 bonds. So another, we require 2 bonds. So what we can do it here, 1, 2, 3, 4, 5, 6. So here I can take double bond. So this will become 3. Here it becomes 5. So I will remove one hydrogen from this carbon and I'll put it on the first carbon. Therefore, we can balance the valency of the carbon. So therefore, see here, I will remove these all the hydrogens and then I will add one of the hydrogen I will shift on the other side. So here I will shift the hydrogen. I will put here double bond H, H, then H, H and H. Now focus. There are how many? 6 hydrogens and carbon valence is balanced. 4 bonds, 4 bonds and 4 bonds. Now see, how many carbons? 3. So the root is prop. Prop means 3 carbon. Then what is the functional group? The bonding is double bond. Double bond means what? Ene. So it is ene. So the name is propene. If you number the carbon, this carbon is 1, this carbon is 2 and this carbon is 3. Therefore, we can write the number of the carbon which is having this double bond. So it will be 1 propene, or you can say pro 1 ene. So like this also you can label. So this is the answer for question 2. That is, give the IUPAC name or the chemical name. Now we will move with. So third question is, you have to draw the electron dot structure for this C3H6. So all the bonds which are present in the carbon, hydrogen, that we have to show with the help of dots. So I will show here one carbon, second carbon, third carbon. As I told, it is a propene. It should have double bond. So one dot, I'll write here, one dot here, one dot here and one dot here. So these are the 4 valency electrons of carbon. So here again one here and one here. So see, like this we have to arrange all the carbons. So each carbon should have 4 valency electrons. Now how many hydrogens we have? 6. So one here I will draw, one I will draw here, then one I'll draw here, one I'll draw here. Total how many? It became 4. So we require another 2. So one here and one here. These 2 here combine to give one bond. So see here, this will combine to give one bond. This will give one bond. These will give one bond. And this down 2 will give one bond. Therefore, double bond. So like this, like this, like this, and like this. So this is the electron dot structure of propene. You have to count the valency electrons present beside the carbon. It should be 4. And then octet it should complete. So now we will see the next question, that is, we have to tell the alcohol which on heating with concentrated H2SO4 will produce hydrocarbon, that is C3H6. So we have to find out the alcohol which undergoes dehydration in presence of this concentrated H2SO4, which is a dehydrating agent, and gives C3H6, that is propene. Now see what you have to think. We want our product as propene and this consists of 3 carbon. So your alcohol should also contain 3 carbon. If alcohol has 3 carbon, then only the product will also have 3 carbon. And which alcohol will have 3 carbon? So first we will take 3 carbon. Then we will write all the bonds for this carbon. See, each carbon should have 4 bonds. It is correct. Now, any one bond you should write OH, that is alcoholic group, and remaining all the bond you should write hydrogen. See, like this. And this is a alcohol. Now it is which alcohol? 3 carbon means it is pro. All the carbons have single bond, so it is ane. But it is having alcoholic group, it is OH, which will be denoted as OL, alcohol, OL. So this E will be replaced by OL. So this is propanol. So if you take this propanol alcohol and if you heat in presence of this concentrated H2SO4, you are going to get your hydrocarbon, that is C3H6. So we will write the reaction here. C, C and C. You can write the reaction like this by writing its whole structural formula, or you can write the reaction by using just a molecular formula. So I'm going to show both. So this is the structural formula of alcohol. You are going to heat it in presence of concentrated H2SO4. So I'll write it here, concentrated H2SO4. This triangle, this is the symbol of heating. Once you heat, as I told, this concentrated H2SO4, it is the dehydrating agent. Dehydration means what? Removal of water. So it is a dehydrating agent. So dehydration takes place, and from this alcohol, water molecule will be removed. So I am going to remove this hydrogen and this OH. So this, once this hydrogen and OH is removed, to balance the valency of each carbon, this bond will shift down, this bond will be removed with the OH. And due to this, carbon will get a double bond here. So what is the product? You will get product like this. So this carbon will remain as it is, and the next carbon down hydrogen will be as it is, but here we are going to get double bond. Then the last carbon H and H. Now focus on the valency. Each carbon have 4 bond, so this is the correct one. And 3 carbons means what? It is prop. Double bond is there means it is propene, so it is propene. And what is the molecular formula? 3 carbon means C3 and H we have 6, so C3H6. So we got our product. This reaction, same thing we can write it by using a molecular formula like this. So I am writing that reaction somewhere here. I'll change the color so that you should not get confused. C3, H how many we have? 1, 2, 3, 4, 5, 6. So I'll write H6 and OH. So this is our propanol, and we are going to heat it in presence of concentrated H2SO4. So write down, and then you write our product C3H6, and we are going to get water. So this water also we have to write. I forgot to write water in this reaction. So here we will write H2O, removal of water. So this is a reaction that is by using molecular formula, sorry, structure formula, and this is the reaction by using molecular formula. You can write any one reaction. It will be correct, and you'll get the full mark for this. So this is the answer for this question. Now the next question is the reaction of C3H6 with the hydrogen gas in presence of nickel. So in this reaction, nickel is acting as a catalyst. So here this is our catalyst which is going to help to increase the rate of the reaction without taking part in the reaction. So nickel will not take part in the reaction. We are going to add this hydrogen gas. So this hydrogen gas, H2 gas, will be added to our propene. So what is the reaction? So let me write the reaction. So here see, C3H6 plus we are going to add H2, and this reaction we are going to do in presence of nickel catalyst. So I'll write nickel on the arrow, and this H2 will be added in this. So we are going to get C3H8, and this is our product. If this is propene, then this will be propane. And as I told here, hydrogen is added. This reaction is hydrogenation reaction, because in this reaction we are adding hydrogen into the substance of hydrogenation. In earlier reaction we are removing the water, so dehydration. I hope you understood. This is the reaction I have done by using molecular formula. The same reaction you can write by using structural formula also. So first write down the structure of propene. So this is the structure of propene. I hope you understood. Now what we will do, we will add H2. So see this, now here we will write our nickel catalyst. So what happens, this H2, one hydrogen will be added here, second hydrogen will be added here, and double bond will become single. So H, C, H, first carbon will be as it is, it will be not changed. For second carbon, we are adding hydrogen, double bond becomes single, H, H and H. So you can see this was alkene, and now here it became alkane by addition of hydrogen. So this is the reaction for last question. So I hope you understood this all the reaction I have explained very in a very basic way. So write these all the reactions in your book also. So now we will move with the next question, that is the OR option of from this question. So the next OR option from this is, that is, the electronic structure of atom P and Q are shown below. So these are the electronic structure of atom P and Q. We don't know the atoms P and Q. So see, this is P, and here first circle is called K shell, second circle is called L shell. Same way in this element also. So in K shell we have 2 electrons, so K shell is full. In L shell it has 1, 2, 3, 4, 5, 6 electrons in P element. In Q element, K shell has 2 electrons which is full, L shell has 8 electrons which is full, and M shell has 1 electron which is incomplete. So this is about Q element. Now, based on the information given above, answer the following question. Now this is the information which is given to us. Now we have to answer the questions. So now the first, that is a question. If P and Q combine to form compound, what type of bond is formed between them? So here we have two type of bonds that we have studied in our SSLC, that is covalent bond and ionic bond. Ionic bond will be formed by transfer of electron, and covalent bond will be formed by sharing of electron. So here we have to see which type of bond it will form. So answer, sodium is a metal and oxygen is a non-metal. Now how to understand that this is sodium and oxygen? Count the electrons. So if you see in the first P element, total how many electrons we have? 1, 2, 3, 4, 5, 6, 7, 8. So see here, P 1, 2, 3, 4, 5, 6, 7, 8. So here we have 8 electrons. So which element has 8 electrons? So here 8 electrons we can see in oxygen. Therefore P is a oxygen element. So I can write it is the oxygen. Now go to Q. Count the electrons. 1, 2. These 8, 1, 2, 8. 2 plus 8 will be 10, and this is 1. So total 11. 11 electron can be seen in which element? Sodium. So it is confirmed that our P is oxygen and Q is our sodium. Now we got the element. Now find out. Now see here, sodium, as it is given, it is metal. Oxygen, it is a non-metal. So we know that metals are always electropositive. What is electropositive? They are able to lose the electron. So these are electropositive. These can easily lose the electron to attain the stability. And non-metals are electronegative, means they can gain electron to become stable. So therefore the answer here, sodium is a metal, oxygen is a non-metal. When metal reacts with non-metal, electron transfer occurs. So remember, metal will lose the electron and non-metal will gain the electron. Now how many electrons sodium is going to lose and oxygen is going to take? You can see here, in case of sodium, K shell is full, L shell is full, and M shell has only 1 electron. So this 1 electron will be liberated or loose. So whatever electron it will be giving, that electron will be gained by oxygen. So you can see in the oxygen, K shell is full, but L shell has total 6 electron. So here we have to add 1 electron, here also we have to add 1 electron, so that total it becomes 8 electron into the L shell. So how to add this electron? So this one sodium will give 1 electron like this, another sodium will give 1 more electron like this, and therefore 1 oxygen combines with 2 sodium by transfer of electron. Therefore here you can see sodium loses an electron to form Na plus, oxygen gains an electron to form O minus. So Na, it was having electronic configuration 2, 8 and 1. Once it loses this electron, because of the losing of electron, electrons are decreased and protons increased. Therefore, Na becomes Na plus and one electron will be lost. In case of oxygen, its electronic configuration is 2 and 7. So it gains one electron. Therefore, oxygen, if it takes one electron, it becomes O minus. But as I told, oxygen will take two electrons. Therefore, it requires two electrons. So it takes two electrons, it becomes minus 2. And this positive Na plus negative O minus 2 combines to give an ionic bond. So here I have written this results in an ionic bond because it is forming positive and negative ion. Now question B, give the chemical formula of the compound form. Very simple. Sodium Na plus, oxygen O minus 2. So sodium, let me write sodium first because always we should write positive first. Na plus 1, O minus 2. This already we have studied in 9th standard. So only valency number we have to cross. So numbers means 2 comes this side, 1 goes that side. So I'll write Na as it is. Positive we have to write first. From oxygen only number comes. So 2 comes. O write down. From Na number comes means 1. So the formula is Na2O. No need to write this one number. It will be understand so that there is a 1. So this is the molecular formula. So this is the formula of sodium oxide. This is the answer for question B. Now we will see the next. Now the next is question C. The compound so formed is dissolved in water. Is the resultant solution is acidic or basic in nature? Justify your answer. So the compound formed is sodium oxide reacts with water to form sodium hydroxide. So you can see here when sodium oxide combines with water it will give NaOH. And metal oxide, always remember metal oxides when added in water they always give basic solution. Basic solution, or you can say alkaline solution. Alkaline is nothing but basic. And non-metal oxides, this everything I have explained in my detailed chapter video. You can visit my channel to see that chapter, that is acid, base and salts as well as metals and non-metals, in which you can see this whole complete basic explanation with all the reactions. So this non-metal oxides when combines with water, react with the water, they will give acidic solution. So this is the basic which you should remember to answer such type of question. So as I know, sodium is a metal, so it is metal oxide. It is metal oxide. And according to our basic, when metal oxide combines with water, it should give basic solution. So this is basic in nature. I hope you understood this. So sodium hydroxide is a strong base, so the solution is basic. Now the next one, question D. Write the chemical equation for the reaction between Q and ethanol. So what is Q? Q is nothing but our sodium. What is ethanol? Ethanol, it is the alcohol which has two carbon and the formula is C2H5OH. When sodium reacts with alcohol like ethanol to form sodium ethoxide and hydrogen gas will be liberated. So here we are getting sodium ethoxide. So how we got this sodium ethoxide? So as we know sodium is a metal, so it will form Na plus. And this alcohol, you can see here alcohol C2H5O and there is a bond between O and H. So if you see, as here O is more electronegative because it will give negative ion, it is a electronegative, and hydrogen is electropositive, it is electropositive. And due to this what happens? Oxygen will get slightly negative charge and this will take slightly positive charge. Therefore, this hydrogen is replaced by this sodium. So sodium comes and take the place of this H and H comes outside. So here we got C2H5ONA and H2 will be outside. So like this the reaction takes place and this the name of this is sodium ethoxide. C2H5O minus, it is nothing but ethoxide ion, ethoxide. and we are adding sodium here, so it becomes sodium ethoxide, and byproduct hydrogen gas will be liberated. Next question, that is, what will be the formula of the compound formed when P undergoes bonding with carbon? P undergoes bonding with carbon. Oxygen can form covalent bond with the carbon because there is no much difference of electronegativity between the oxygen and the carbon. They share the electrons, and because of the sharing of electrons, whatever bond will be formed, that bond is called as covalent bond, and therefore we are getting covalent bond between oxygen and carbon. So what is the simple compound formed between the carbon and the oxygen? It is called carbon dioxide, that is CO2. And how the structure looks, that is C double bond O double bond O. So this is CO2. With the help of this formula, the octet of this oxygen as well as this carbon will be attained, and therefore the structure of carbon dioxide is CO2, where each oxygen forms double bond with the carbon, and these bonds are covalent bonds. Remember, covalent bond means what? Covalent bond, the bond is formed by sharing of electrons. Remember this. These bonds are formed by sharing of electrons. So this is the answer for this question E. So here I have completed the whole section B chemistry from CBSE sample question paper class 10 2025-26. I hope you will understand each and every question which I have explained in these all the videos. Now before this I have uploaded the biology section, that is section A, and now this I have completed section B chemistry. After this I'm going to start with section C physics. So watch my videos, like my videos, and share my videos with your friends. If you have any doubts regarding this question paper, it may be from biology section or chemistry section or physics section, you can comment those doubts in the videos so that I can prepare a separate video for your doubts, and I will upload those all the videos in on my channel so that it will help all the students. So please consider subscribing my channel if you are getting little bit also help from these all the videos. Thank you so much.